In this module, you will learn about adding methods dynamically, accessing attributes and methods, using built-in class attributes, using delete and string methods in a class, data hiding, static methods, destroying objects and garbage collection. Let us now learn about adding methods dynamically. One way can add, modify, and delete the attributes of a class dynamically, that is, at runtime. Similarly, methods can be dynamically added to an object or a class. Consider the code shown on the screen. In this example, study is just a function which does not receive self. There is no way by which E can know that study is a method. If self is required, create a method and then bind it to the object. To do this, import method type from types module. Take a look at the following example to understand this. In the example we have seen so far, the built-in function method type from the types module takes two arguments. First is the name of the function, which has to be bound dynamically, and the second is an instance with which it has to bind the function. In the example, the study method will be bound only with the instance E. No other instances of the class exam_result will have the study method. For the other instances to have this method, add the method to the class by making use of self. Take a look at an example to understand this. From the example shown here, you need to note you cannot create any method using method type because all functions in the body of the class will become methods and receive self as long as you do not make it a static method. You will learn about static methods later in the module. Accessing attributes and methods. The attributes of a class can be accessed even by using the built-in methods or functions like getAttribute, which are used to access the attribute of object. Such functions are called when the reference attribute in the class has not been found in an attribute lookup. The built-in method for this will be object. The getAttribute method is automatically invoked if the referenced attribute is not found. An example is provided on the screen. The statement shown in the example returns the value of the marks attribute, otherwise raises an attribute error exception. You need to remember that if the attribute is found through the normal mechanism, the getAttribute method is not called. The hasAttribute method is used to check whether an attribute exists or not. For example, the following command will return true if marks attribute exists. And in order to set an attribute, setAttribute method is used. Alternatively, the following built-in method is invoked when an attribute assignment is attempted, where name stands for the name of the attribute and value stands for the value which is to be assigned to it, and an attribute would be created if it does not exist. Take a look at an example. The built-in method for the same will be as follows. Either of the given statements, set the value of the attribute marks as 90. The delete attribute is used to delete an attribute. The built-in method for this attribute will be as shown. Take a look at an example shown on the screen. The code shown on the screen deletes the attribute marks. The built-in method for the same will be as follows. Let us now learn about accessing methods. When you reference an instance attribute other than the data attribute, the corresponding class is searched. And if the attribute is a valid class attribute, a function object, a method gets created by pointing to the instance object and the function object. When you invoke this method object with an argument list, a new argument list will be constructed from the instance object and the argument list. Then, the function object is invoked with this new argument list. The methods of a class can be accessed in the same manner as the data attributes, that is, object name dot method name. Now, putting all the concepts together, let us see the following example. The statement E2 equals to exam underscore result will create an object or instance E2 of class exam underscore result, assuming marks is 90 and final grade is A+. It is not necessary that a function object should be always textually enclosed in the class. You can also assign a function object to a local variable in a class. For instance, in the following example, A, B, and C all are the attributes of class example. They refer to the function objects and hence are all methods of instances of the class example. You can also reference methods by global names in the same way as you do for normal functions. The global scope associated with the method is the module containing its definition. Although we use global data in a method very rarely, functions and modules imported into a global scope can be used by methods, functions, and classes defined in it. Very often, a class containing the method is itself defined in this global scope. Look at the example on the screen. As you notice in this example, B.TECH is a method object and is stored in BF. It can be called later in the while loop. It is not required to call a method right away. In case of methods, you need to pass the object as the first argument of the function. So, even if you do not give any argument in the function call while defining the function definition, you will not receive any error. In the above example, P.F is exactly equivalent to example.f. So you can say that calling a method with a list of n arguments is equivalent to calling the corresponding function with an argument list that is created by inserting the method's object before the first argument. Let us now learn about built-in class attributes. You will find that every Python class keeps some built-in attributes which can be accessed using dot operator like any other attribute. Let us now learn about them. The first built-in attribute is dict, which gives the dictionary containing the namespace of the class. The second one is doc, which returns the documentation string or doc string of the class, and if there is no doc string defined for a class, this built-in attribute returns none. The third attribute is the name function, which gives the class name. And the fourth attribute is module. This specifies the module name in which the class is defined. In the interactive mode, this attribute is called _main_. The fifth attribute is called bases, which gives a possibly empty tuple consisting of the base classes in the sequence in which they occur in the base class list. Let us now try to access all these built-in attributes with the help of an example as shown on the screen. When you execute this code, it produces the following output. Let us now learn about using the delete function. You invoke this function when the instance is about to be destroyed. In other words, it destroys the instance and hence it is also called a destructor. It calls the method object.delete function. When you invoke delete function in response to the module which is being deleted, it so happens that the other global variables referenced by delete method may have been deleted already or may be in the process of being deleted. In order to understand the concept, consider the example of class marks whose instance is M1. The command given will be delete M1. This command doesn't invoke M1 delete function directly. First, the reference count is decremented for M1 by 1 and delete function is called only when M1's reference count reaches 0, that is, when all the variables referenced by M1 have been deleted. Let us now learn about using string function. This is a special function and it returns the string representation of the objects. It invokes the method object.string function. If a string method is defined by the class, Python will invoke it when you call the str function or use print statement. When the str built-in function is used along with the print statement, it computes the informal string representation of an object. Take a look at an example of the class test defined shown on the screen. Now give the following command on the Python interpreter. When you give the command to print t, Python invokes strt function to get the string representation of t. If the class of t has a string method, strt becomes a call to t.string method. This returns the string to print. Let us now move on to learn about private members. The variables that cannot be accessed from outside the class are called private instance variables. These attributes can be accessed only from inside an object. When you want to hide an attribute, you would use these attributes. However, these types of members do not exist in Python. In case you still want to hide a member, a limited support is provided by Python, and this support is called name mangling. According to this name mangling, a name is prefixed with 2 leading underscores and 1 trailing underscore will be considered as a private member. For example, _private_ will be considered as mangled and so will be treated as private members of the class, but not as shown here. When Python encounters these name-mangled attributes, it transforms these names by a single underscore and the name of the enclosing class. Let us take a look at an example to understand private members concept. On execution of dir function, you will notice that the attribute marks is prefixed with an underscore and the class name. Let us now move on to learn about data hiding. Data hiding is a means to procure encapsulation. However, data hiding is not enforced by Python in the real sense. The approach taken by Python is by simply not using private data members. As we have learned earlier, for something which is particularly private, you can use the double leading underscores to mark it. But this is more an act of marking. Actually, this works like a reminder that such data can be used only within the class. You need to remember that Python is a dynamic language, and hence attributes or methods can be added dynamically on an object. Take a look at the example on the screen, in which the attribute average is dynamically added to the class exam_result through E1. If you look at Python's sense of encapsulation, you need not worry about the details related to implementation. Also, you need not worry whether or not an attribute has public or private access. A leading double underscore means that an attribute is private. It means if you try to access the attribute directly, you won't be able to. And this is done by secretly name-mangling the variable with a leading underscore, the name of the class, and then the name of the variable. If you try to access this hidden attribute, then an error message will be displayed. In this example, underscore marks has been defined as private. So when you access it from outside the class, you will receive an error message. Also, when you try to import using the command from my module import star, anything with a double leading underscore doesn't get imported. However, you access the private members as shown in the following example. Next, let us move ahead to learn about static methods. A static method of a Python class is a method that does not obey the usual convention in which self, an instance of the class, is the first argument to the method. Static method is just like any other function defined in the class, but it is callable without creating the instance of the class. Static methods belong to the class. However, they don't use the object self at all. You can declare a static method by declaring the method normally and preceding it with the built-in static method decorator called @static method. You can use static methods when methods do not need to reference the self variable. Here is an example that illustrates the use of static method. In this example, the function show is not having self as the first argument. That means it is being called without the instance. Static method eases the readability of the code. Reason being, once you see @static method, you know that the method does not depend on the state of the object. Once you declare a method as static, then the arguments you pass to it are exactly the arguments it receives. Static methods return the underlying functions without any change. As a result, the function becomes identically accessible from either an object or a class. Here is an example. Let us now learn about destroying objects, garbage collection. In case of Python, the memory is automatically allocated and deallocated. You do not have to pre-allocate or deallocate memory manually, just as you would do when using dynamic memory allocation in languages such as C or C++. Two strategies are used by Python for memory allocation: reference counting and automatic garbage collection. Let us know about them. The first is reference counting. Before users started using Python version 2.0, the Python interpreter used only reference counting for managing memory. Reference counting works by counting the number of times an object is referenced by other objects in the system. The garbage collector in Python runs while program is being executed, and when an object's reference count reaches 0, it is triggered. An object's reference count changes as the number of aliases that point to it change. The reference count increases when a new name is assigned to it or placed in a container, list, tuple, or dictionary. The object's reference count decreases when it is deleted with del. Its reference is reassigned or its reference goes out of scope. When an object's reference count reaches 0, Python collects it automatically. Consider the code given below. Y is equal to 20. An object Y is created, which is bound to 20. X is equal to Y, increase in reference count of 20. Z0 is equal to X, increase in reference count of 20. Delete Y, decrease in reference count of 20. X is equal to 10, decrease in reference count of 20. A class can implement the special method _delete_ called a destructor, which is invoked when the instance is about to be destroyed. You can use this method to clean up any non-memory resources used by an instance. Reference counting is extremely efficient, but cannot handle reference cycles. A reference cycle is when there is no way to reach an object, but its reference count is still greater than 0. The easiest way to create a reference cycle is to create an object that refers to itself as in the given example. In this example, since reference _cycle creates an object Y which refers to itself, statement Y dot append X, Y will not automatically be freed when the function returns. This will cause the memory that Y is using to be held onto until the Python garbage collector is invoked. Let us now learn about automatic garbage collection. In this method, garbage collection is a scheduled activity based on a threshold of object allocations and object deallocations. Python schedules garbage collection. The objects which are not required are deleted by Python, may it be built-in types or class instances, using the process named garbage collection. When the number of allocations subtracted from the number of deallocations are greater than the threshold number, the garbage collector is run and the unused block of memory is reclaimed. The threshold can be inspected for new objects by loading the GC module and asking for garbage collection thresholds. If your Python device is running out of memory, then automatic garbage collection will not run. In that case, your application will throw exceptions, which must be handled, otherwise your application will crash. Also, the automatic garbage collection occurs more for the number of free objects than the size of objects. In this module, you have learnt that a special method which is used to initialize the data members of a class is called a constructor. The built-in method init is a type of constructor in Python. In Python, in every class method, the first argument, including init, is a reference of the class, and this argument, by convention, is always given the name self. Self is an instance identificator and is needed to ensure that the statements within the methods can have automatic access to the current instance attributes. Instantiation is a method of creating instance objects. In order to create instances of a class, you call the class using class name and pass in whatever arguments its init method accepts. Class attributes belong to the class itself and are shared by all the instances. These attributes are defined at the top in the class body part to ensure legibility. Every Python class keeps some built-in attributes, which can be accessed using dot operator like any other attribute. Data hiding is a means to procure encapsulation. Reference counting and automatic garbage collection are two strategies used by Python for memory allocation.